All right, this second video for section 7.4 is going to cover example 3, which talks about finding the area between two polar curves. In the last video, we found the area inside just one curve. And example 3 says to set up an integral to determine the area that lies inside r equals 3 plus 2 sine theta and outside r equals 2. So let's start again by graphing those. That's always a good place to start. My curves were, the first one was r equals 3 plus 2 sine theta. And then my last one was a circle, r equals 2. All right, so let's take this graph. I'm gonna snip a little copy of it here. And so the area we're talking about is between the two curves. The area we're talking about is basically all this stuff between the green and the purple curve, right? So the angle that's going to be important for us is basically the angle at which those intersect, which it looks from the graph here, it's going to be right there is where they intersect, and right there is where they intersect, right? So and it looks like, I mean, those are right on, this one's on 11 pi over 6, and this one's on 7 pi over 6. But how can we know for sure? Well, just like with Cartesian coordinates, the way we find where two curves intersect is we set them equal to each other. And so we're going to do the same thing here. Let's go back to our notes. And we'll make a little note here. So we'll say note to find the bounds for theta. We need to find where the two curves intersect. All right, so find where the two curves intersect. We can set them equal to each other. That means that 3 plus 2 sine theta must be equal to 2, because they're both equal to r, right? They both equal r, so we can just set them equal to each other. Let's go ahead and subtract 3 over to the other side. Subtract 3, and when we do that, we get 2 sine theta is equal to -1. What's our next step? Our next step, divide both sides by 2. So if we go ahead and divide both sides by 2, we get sine theta equals -1/2. And then we're going to use inverse trig, right? So theta is equal to the inverse sine of -1/2. Where is sine negative? Sine is negative in quadrants. We're in quadrants 3 and 4, and it's a -1/2, which means that we're going to be dealing with 7 pi over 6 and 11 pi over 6, which matches up perfectly with our Desmos graph, right? So our graph, this was at basically 7 pi over 6 and 11 pi over 6, so that's perfect. Now the one thing to remember is, remember we talked about in the last video, as we accumulate all this red area that I shaded in here, remember it always starts moving counterclockwise. So it's going to start here at 11 pi over 6, and it's going to accumulate counterclockwise all the way until you get to 7 pi over 6. The problem with that is that we need to go from a bigger angle to a smaller angle. We need to go from a smaller angle to a bigger angle, and this 11 pi over 6 is actually bigger than 7 pi over 6. So equivalently, we could say instead of 11 pi over 6, how about negative pi over 6? Negative pi over 6 as our angle. So we can go ahead and notice the The directions here just said to set up. So our area is going to be 1/2 of our integral from negative pi over 6 to 7 pi over 6. And now because it's between two curves, just like we did with rectangular systems, we need to subtract the outer curve minus the inner curve. Well, the outer curve was the green one. Actually, let's go to Desmos. The outer curve was the green curve. So that was the 3 plus 2 sine theta. The inner curve was the purple, the circle, r equals 2. So what we're going to have is we're going to have the outer curve squared minus the inner curve squared d theta. And the other cool thing we can do here is just to confirm, we can go ahead and change our bounds. So make sure that we're getting the right amount here. Let's change our lower bound here to negative pi over 6. And let's change this bound to 7 pi over 6. And there you can see it restricts that green curve. Of course, you could also have done that with our graphing calculator as well, just to confirm that we have the right region we're talking about. I suggest, again, that you include that sketch in your notes so you can reference back what you're doing, but this is how you find the area between two polar curves. Let me know if you have any questions. That's going to do it for this video. Thank you.